Let's talk a little bit about projections and coordinate systems. This is another foundational concept for GIS and the root of many problems when you are importing your own GIS data into ArcMap or another GIS software. There are two parts to learning about coordinate systems and projections. First is the science behind it, why we need them, why we use them, and the second, that practical application. How do we deal with issues related to projection in ArcMap? So you'll sort of get two sides of this week. The lecture will focus a lot on the science, and then at the end gets into what you're actually doing. And the exercise this week will really go into those details. So the science behind it, I don't want to take a lot of time in this video really going through the details of it because it can get quite complicated. Instead, you've got a pretty detailed lecture and several links in Canvas that are going to help you illustrate some of the more complex topics. But really, the idea behind coordinate systems and projections boils down to the idea that we have to figure out how to represent the 3D surface of the Earth on a 2D piece of paper or on your computer screen in a 2D format. You'll watch one video this week, and hopefully it'll give you the idea that this is incredibly complicated. Luckily for us, a lot of people have figured out the math behind getting that 3D space onto a 2D space already for us, so we don't have to worry about that. But we do need to understand why coordinate systems are important. So we'll look at geographic coordinate systems, we'll look at projected coordinate systems, make sure you understand how the two are different. Also in geographic coordinate systems, we get into the concept of datum, and this is really complicated and hard for some people to understand. So again, there's a lot of videos on Canvas about it. But when we talk about datum, we're basically just talking about a mathematical model that approximates the shape of the Earth. Why do we need that? We have to have an approximate shape of the Earth to get really accurate position, location, and area calculations. Fortunately for us, with the dawn of GPS technologies and other really high-resolution imagery and high-resolution positioning satellites, we've gotten a lot more accurate in where things are located. But understanding which projection, which coordinate system, which datum you're using will help you avoid the errors of lining up your data correctly. We'll talk about in the lecture that there's two types of datum, one that will give you the shape of the entire Earth, or average out the average shape of the entire Earth, and the others are for your local areas. So you need to decide, what is my study area? Do I need to display the whole Earth? Or do I need something that provides a really accurate depiction of San Diego County? And we'll look at some examples of those datums in the lecture, and then further in the lecture, some of those projections that will help you get the most accurate representation of your study area, so you can have the most accurate calculations of area, length, position, making sure the things you put on your map are where they're actually located in the field. In terms of the application side of things, the labs are going to make dealing with projection look super easy. I'm looking for a book. Look super easy and very simple. It is rarely that way. Esri puts out a whole book on how to line up your data. It's rarely as easy as they make it look in the textbook, but it does give you that checklist of what to do first and what to do next and what each warning sign means, which tool you use. So you will be coming back to this. I come back to this lab in the textbook frequently when I'm having issues with projection, just because it's a good place to start over. So if this all doesn't sink in this week, don't worry, you'll have plenty of time to practice dealing with projection. But make sure you take some time, really think about the terms you're learning, why you're learning them, and what they're showing us.